Hello, hello. Um, did I start the stream? Yeah, I did. Okay. Nice. So we're going to work on the language again. Today, after like 3 days of working on the lecture, I guess we're ready to kind of move on to the parsing of the AST of the language. So let's take a look. The AST of kast. There is no built-in syntaxes except for syntax for defining new syntaxes in the language. That's how the language is working, and that means that the AST is represented by these things. So it's either a simple token or it is a complex thing which is defined by a certain syntax definition, right? So this is what the syntax definition looks like in code. We have the syntax for, in this case, the ternary operator, in case we want to have it, associativity of the syntax, priority of the syntax, some names of the things that I want to bind. So this can be like any other AST node, basically, with the higher priority, or the same priority, I guess. Yeah. So basically, when we are parsing this is going to be recursively parsed by any other syntax definition, and then this is going to be like presented as the AST, which is then going to like be stored here, right? So like this is a tuple of AST nodes, because like and then a tuple in our case is going to be a structure which is going to have both named and unnamed fields, right? So a list of unnamed fields and a map from the name into the named fields. Because in this case of a ternary operator, we are naming the condition, the then case, and the else case with the names of the condition, then, and else. And in case of some simpler syntaxes, maybe we don't necessarily want to name things, we just want to have like positional things, you know. So yeah, ternary AST is so basically like when this is being passed into the macro, which is like a normal function, this accepts the tuple where every field is AST, and we can have these fields named or unnamed, basically, depending on what we want. Previously, in the previous implementation of a language, I only supported the named things, but I think I want to support the unnamed things too. When I'm going to rewrite it into Haskell here. Another thing that I never supported in the previous implementation was the repetition. So if we take a look at the standard syntax, this is the syntax for the language, right? So let's take a look at the tuple. So this is a built-in macro tuple syntax for this, and all it says is a comma b, right? And it's specifically for the tuples, I think we would make this unnamed. So yeah, that's like the thing. But I was thinking that I'm not sure if I want to actually, but maybe if I make this to be like you know, something like that, so that we start with the first element of a tuple and then we have as many commas as we want. But I'm not sure if we actually need it. Because we can do it later to like convert it to list. I think like just I have a problem in my current implementation where like if I do nix run my language, right? If I say something like hello world, this is a tuple of 2 strings, right? But it works because comma is basically like a binary operator which takes 2 things and like combines them into a tuple, which means that if I do hello, or if I do like A and B and then comma C, this is... Wait, hold on, this actually still works. So I actually do this correctly then. I thought it would be like a tuple of 3 strings instead of a tuple of a tuple and a string. Okay. Why does this work? Maybe I don't remember how my implementation works. Yeah, I don't know. I'm just like thinking that if I could like have the repetition here, does it help or not? I don't know. I guess for now I'm just going to like rewrite it as it was before. The only thing is that I'm going to make this unnamed, you know, the only difference. Because I think sometimes naming things is a little bit annoying, like just A, B, not really meaningful names, right? It's just like the first and the second thing. So yeah, let's start. Let's start. So once again, we have the syntax definition and the values for that syntax definition. That is what we want to parse our thing into. And sometimes we can have like an empty node, right? Do I want to be able to have the empty, actually? Nothing. I kind of don't really want to have the nothing here. What was this used for? I don't remember. Let's not have the nothing here for now. It's like, you know, when I'm parsing the file, if the file is empty, it still needs to be parsed into something. And I guess that's like the only edge case. But at the same time, the inner nodes in our AST, in the tree, should never be nothing, right? Or can they be nothing sometimes? Maybe they can be, like, if I have the if I have like the bracket like this, then inside over here, inside this, we have nothing. So this is a parenthesized expression with nothing inside. I'm not sure. If I will need to, I'll add it later. Source state. What do I think? Source state monad M. I was doing something. File name token. Let's delete everything here. This is what I need. State static shared, sure. Okay. So the lexer is a thing which takes the source file and converts it into a list of spent tokens, right? Now the parser of the AST is the thing that is going to take the list of spent tokens and is going to convert that into into an AST, right? Yeah. I will probably make this the effectual stuff so that like we can log some stuff, right? Because yeah. So like that. If I want to use logging, then I will do that here. So parse is to do from my prelude. I kind of wanted to like delete my prelude actually. I'll import I will call it the util instead, utils. And my prelude is something that I wanted to completely delete. Right? So string, I'm just actually importing the normal prelude instead. I think that's fine. Syntax, my prelude does not need import prelude. Tin. Yeah, and like to do is just error to do like that. You know. I want to export this. Okay. Before I can parse anything though, I need to construct the thing. Which is like the state machine of how am I going to do the parsing. So since I have a bunch of these syntax definitions, right? I'm not going to just like go in order and try them, and then if it fails, then I'm going to like retry. That's not how I want it to work. That's not how it was working in my previous implementation either. Instead, we take all of the syntax definition and I construct the like the state machine, kind of, which basically when I'm going through my tokens, I'm just changing my state. So that we can parse the entire file in one go without like retrying the parsing, you know? So like we will take just linear time to parse the entire thing. I'm not sure if like it matters too much. But I think in order to not think too much about the things, I'm just going to do things just like I was doing before. Just going to improve on it a little bit. So the way it works is like, what's a good example? Like, for example, over here, right, we have two different syntaxes for defining templates. One of them includes the where clause, and one of them does not, right? So, like, the beginning over here is the same. So when I'm parsing the thing, I have like both of these start with the same keyword for all, right? So in case this fails to be parsed, I don't want to restart and parse the for all again. Instead, we merge. So like when I see the for all, it's going to like advance the parser state into the state where I know that the for all has already been parsed, and only where we diverge, right? So like until this point, the prefix is all the same, so the state that we're going to be in will be the same, and then based on like the next keyword, we're going to like know what exactly is the thing that we're parsing. Is how this works. So over here in this syntax, I'm going to say what is the how to construct this this state machine. I'm going to do it here, even before we do any parsing. So so once again, the syntax definition is something that has the name, associativity, priority, and like the actual definition, which is a list of parts, right? In this case, we have a named like child, which is named cond, and then we have like the we expect specifically the talking question mark, which I'm calling that a keyword. Anyway, can be like punctuation or the actual keyword, doesn't really matter. So yeah, this is the syntax definition. So out of like a bunch of these syntax definitions, I want to construct the state machine. So we are going to have the state, right? State like parse state for parsing a single for parsing a single syntax, basically, right? When I'm parsing a single syntax, deriving show. I'm wondering, like, does deriving show work with recursive data structures, or is it going to like infinitely do that? Well, I mean, the only way if it's going to be like actually like pointing to itself if it is if I wanted to have the repetitions. I guess I'm not doing that yet. Anyway, doesn't matter. Over here, I'll say that the parse state is what. So like I am currently in some state and I want to advance into a different state, which is going to happen when we have when we're encountering a keyword, basically. So so next is when I have a keyword, or like, I mean, it's going to be a map basically from edges into the new parse state, right? And then what is an edge? An edge is not just a keyword. Edge is the thing that has the keyword, which is a string, a specific thing that I'm expecting, right? Link commas don't work. Okay. Use new type. No, I don't want to use the new type. And also, before the keyword, we potentially can have a couple of values, you know? So the amount of values that we want to have here is can be like technically any number. It can be 0. It can be 1 value. Maybe... I'm not sure if I want at any time to have like more than 1. There's only one syntax that has more than 1 values, one after each other, which is like a function call. So when I have function and then arguments, this is 2 values next to each other. One value is the function itself, the next is the argument. But that does not have a keyword in between. And in order to like do something like that, and if I'm in the parse state, sometimes I want to be able to finish parsing, right? And if I want to finish a parsing, then that is going to be a map from int, which is like the number of values before I finish, into the actual finish state, and the finish state is the original syntax definition. I think is how it works. Okay. Yeah, I think that is it. And then the syntax of the language is basically a collection of syntax definition converted into the state machine like this, with the root parse state, right? Root state being the parse state, like this, and then we can go through from there. The keywords list is a set of strings which are considered keywords. Just because, why not? And then the root state. Is that all I need? Might be all I need. Okay, so then I need to be able to so yeah, let's see. So empty syntax is the syntax that we are going to start with. Right? So the keywords, we by default have data set empty. By default, we are going to have the empty set of keywords, and root state is our state where we cannot finish anything. So this is data map empty, and next is also data map empty, right? Like before we introduce anything, right? Then we're going to parse the syntax definitions, right? And we're going to need to add syntax definition to the syntax, right? So we have the syntax, we have the syntax, the new syntax definition. Like maybe I should rename this syntax to like, because this is like the collection of, I mean, is there like a syntax like plural form, or is syntax plural form is the syntax? Plural syntaxes. I don't know. I mean, I don't know. I'm just going to keep this be called syntax. But anyway, we have syntax. We add this definition to the syntax and we construct the new syntax as a result, right? To add syntax. Add syntax. Syntax definition is what? Right? So over here, what I'm going to do is we are going to go through the parts, right? So we're going to start adding this syntax definition to the root, right? And keywords are going to be updated with all the keywords that we see in this syntax definition, basically. Yeah, so let's see. We're going to have syntax keywords is update keywords. So syntax keywords are going to be updated with the definition parts. There you go. Oh, I know that like the edge needs to have the priority too. I forgot about that. But yeah, we'll see while implementing this anyway. And then the root state is going to be you know, insert definition something into the syntax root state. I'm going to insert once again the definition hello there parts from like the definition. Zada Saver, hello, how are you doing? Let's see, update. Davey is here. Hi Davey, how are you doing? One of these days I'm going to continue working on Linksider, Davey. It's going to happen. Are you doing anything? I saw that you did the font. Great, you Haskell, yeah. You Haskell? You like Haskell? You know Haskell? Sure, Kappa. Okay. Update keywords. So update keywords is the easy one. We take this set of strings, which is the current keywords. We take the syntax definition part list, and then we construct the new set of strings. Set of strings is set string. Update keywords is, let's see, in the data set there is probably a function which is called like, so we can insert, obviously, right? But this is inserting just one element. What about, can I have the auto-completion only from this module somehow? Why is it auto-completing from everything else? Annoying. Intersection in it. Okay. I think it's easier to just go into the documentation. Haskell set. What's the easiest way to like... Wait, hold on. Can I go to the definition? Documentation. Source. Okay, yeah, I literally can only do this by going online. Can I go to, like, I cannot even see the documentation without going online? Okay, whatever. Maybe I can. Somehow. Maybe I need to, like, generate this documentation to be able to do that. Warning, this model is considered internal. Why am I here then? Why am I here then? Because this is dataset internal. Where is the normal dataset? I have no idea how to navigate the documentation. Data set. There you go. So this is the one that I want. Insertion. To have insert, we have delete. This is inserting just one thing. What is this not online you speak of? Well, the local documentation. Like what if I am working on my project, like on a plane or like, I don't know, somewhere where I don't have access to the internet? That can happen sometimes, you know? How will I be able to write my my Haskell code? With Rust, I can like look at the documentation locally. I assume there is a way to like generate the documentation of every single package that I'm using locally, because I have them downloaded, right? I have downloaded all the packages. I just need to generate this documentation and open it, probably, right? There's probably a way. Anyway, what I'm looking for is a function that takes, like, I guess, a list or maybe anything foldable, and then inserts all of those things into the set. Instead of me inserting things by one by one, right? Generalized, Alt F. Can delete or insert X in S depending on whether an equal element is found in S. Bool F bool. A set A. F set A. Query. Fold. Combine. Union. Unions. Like, I guess I can do a union and construct a list out of a set. A set out of a list, maybe. I don't know. Conversion. Yeah, like elements and to list. Is this different? To list and elements and aliens to ask list in ascending order? And this is not an ascending order. This is any order. Random order. Debugging. Show tree. List. Holds. Okay, it looks like I don't see the function, so I guess I need to insert the things one by one. Okay, I mean it's not that bad. Inserting things one by one is not that hard. Update keywords. I mean, it's probably like what are the instances of this set type? Like maybe I should take a look at this here. Maybe anything foldable can. I mean, foldable is something that I can fold, right? I like it should be more like insertable or something like that, right? Like a general type class of things that I can insert new things into, right? And I don't see anything like that here in the base. Anyway, so in update keywords, so we have the current keywords and we have the and then I'm going to do the case, right? So if I have the empty list, then I'm going to keep it as is, right? If it is a keyword, keyword followed by the rest, then I'm going to update keywords using the rest by, but I'm going to data set insert the keyword into the keywords and then update it with the rest, right? And if I have the anything else and then the rest, then I just update the keywords without inserting anything there, using the rest, right? Just like this. So this is easy. But if I had like the function, it would be a little bit shorter, I guess. Well, anyway. Now insert the definition. Insert definition is a function which takes the state, takes the syntax definition parts, and updates this state, right? So that we can go from this state to parse the remaining parts of this list. Let's see. Insert definition is insert definition state is, so I'm going to do the same, right? Case, or I guess actually, you know what? Insert definition state. Or I guess I'm going to say insert definition is insert definition impl with 0, because because my edge contains the amount of values that I see before the keyword, because like I'm not jumping into the next state if I'm seeing anything other than keyword. So I need to like group the values together and only construct the edge when I see a keyword, basically. And then I say where insert definition impl is a function from int into parse state into syntax definition parts. No. Why does it not being auto-completed? Type signature lacks the thing, yeah. So this implementation is so I have the amount of values, and then I have the current state, and then I am going to do the casing of the list. If it's an empty list, in this case. So this means if we have an empty list now, it means that I have finished the definition, right? And this means that this is the end, and the current state should be able to be finished, right? So I'm going to update the finish map here. Parse state. Disable missing field warning. No, I don't want to disable the missing field warning. I want to like automatically fill the fields for me. No, Haskell language server cannot do that. Okay, that's fine. So so next is going to be the same as the next before. So stay.next, and the finish is in this case I'm going to update the finish, right? Data map update at. Wait, let me take a look here. Data map. Want to why am I seeing the documentation for the lazy? I don't know. Maybe this is what I'm going to look at. Singleton from set. So there is a function that is called update. Adjust. Update a value at a specific key with the result of the provided function. So this is just taking the existing value and then modifying it, right? At a key. When a key is not a member, the original map is returned. That's not what I want. No, I want to update. Updates the value x at k if it is in the map. What if it's not in the map? I want to update even if it's not in the map. What I want, I guess, is the alter then. So maybe a into maybe a, yeah. I mean, technically what I want is maybe a into a. Maybe I should like Google it here. Google. Let's see. So what I want is a function which takes you know, like maybe a into a, and then it takes the key, and then takes the map key a, and then returns a new map key a, right? That's what I want. No results found. So, but if I do the same with if I do the same with maybe, then that's the alter stuff, right? Yeah, okay. Sure. We can do that. We do the alter. So I'm going to alter at, so the key is the amount of values. So the values. The thing that I am updating is the current finishes. Yep. And this over here is going to be the function, which should not have been there, right? So what if I want to do over here in the altering lambda, like this must be a pure function, right? But what if I wanted to do like something effectful there? Is there like alter, I guess alter f is the one, and then if I use this with a monad, right? Then I will have a monadic action of inserting, right? Inspect, insert, delete, or update a value in a map. Alter F is the most general operation for working with an individual key. Use the trivial functions like identity and constant, always slightly slower than the more specialized combinators. However, when the function is non-trivial, it is the fastest way. Note on the rewrite rules. Includes the GC rewrite rules to optimize ultra F for the constant identity functors. So yeah, because like I want to be able to what? I want to be able to like throw the errors. But I wanted to do that with the I mean, I can use the normal exception stuff in Haskell, but it is not like typed. Right? Anyway, I guess I'll just throw an error for now. Let's start with some implementation here. So existing thing, right? And then I guess I'm just going to case here. I'm going to case if it was just something that was existing. Then I'm going to throw an error where I'm going to say like, you know, duplicate syntax definition, because that's the only thing that it can happen, you know, because it's a duplicate syntax definition. Yeah. And if it is nothing, then I am going to instead insert. I'm going to do just, and the thing that I'm going to insert is the new finish, which is just the syntax definition itself, right? Just definition, which means that I need to have the definition here. I'm going to make the definition the first argument here. Insert definition. So syntax definition into there. Insert definition like that. I'm going to capture it and I do that here. All right. So this is done. This is when we have finished the list. Then I can finish parsing the syntax, right? And if like over here, I can, you know, let's do error duplicate syntax definition colon something like show existing name and show definition name. So these are the two ones that actually like conflict with each other. Can I do that? Nice. Okay, next. Now if I have a thing which is a keyword followed by the rest, in this case I need to do the thing, and if it's not a keyword but anything else followed by the rest, like over here I'm going to do a to do, and over here if it's anything else followed by the rest, which is like the actual value, named or unnamed, it doesn't matter. In this case I'm going to just insert but the amount of values before the keyword is going to be increased by 1. State rest, like that. Variable not in scope to do, yeah, sure. Keyword rest. So in this case, since I'm seeing a keyword, the finish is going to remain the same. But in this case, we update the edges, right? So in this case, we do data map, where I'm going to alter the thing, right? I'm going to alter the thing, which is the I'm going to alter the thing at the edge which means that I need to construct the edge, right? Let edge be edge, right? Like this. So at the edge, I am altering the state next, right? The edge is a thing which has a keyword and has the amount of values before the keyword, like that. Right? So over here, once again, I'm going to do the case. In this case, the conflicts, like if something is already existing, then it's okay. So basically, I'm following that edge into some existing state, and then I'm going to update that existing state. I'm going to update this existing state into the thing. Which, you know, I'm just going to say over here, like current into something like let current I don't know, I'm not sure what to name it, like existing or empty, because that's what I'm going to do, is going to case current of just existing. Then I'm going to take the existing state, right? And if it is nothing, then I am going to like initialize this state to an empty state, right? This is empty syntax. Let's have the empty empty parse state or state over here. Empty parse state is this. Right? So if it's nothing, then I initialize the empty parse state. The autocompletion doesn't work because it is not going to work until I fix the syntax, I guess. Which means that I need to finish this, right? Now it works, okay. So now I basically get the existing entry in the map, or insert a default value, which is an empty state, and then I'm going to update that state, right? I'm going to insert definition impl. So I'm starting with 0 values again. And I'm now updating this existing or empty thing using the rest of my syntax definition. And then it's going to be the thing that I'm inserting into the map. Replace case with from maybe. Oh, there is a from maybe which gives me the which takes the default value, right? Yeah, okay. Nice. So we just do I just inline it then? Like that. Just need to import the from maybe. Right? No instance of ORed edge. Yeah, so like the edges, since I'm storing this in a map, must derive the ORed. Is that how I do it? No instance of edge. So in order to have the ORed, I need to also derive the act, right? Makes sense, makes sense. Makes sense. I think that's it. this is how I construct my state machine, and then we're going to use this thing to actually parse the AST. There's also like the priority that I lost, which is going to be stored in the edges, by the way. And yeah, and this is where the yeah, I guess I'm going to potentially have the conflicts there, and then I should throw the error. Anyway, I need to take a bathroom break real quick, and I will continue. Wait, it's not food. Bathroom. Okay, I'm back. Sorry. Okay. Hello, elemental magics. How are you doing? If you're still here. That was a long bathroom break. How are you doing? I think last time I saw you in chat, I was working on the camel version still. As you can see, we're writing Haskell now. I'm rewriting kast into Haskell slowly. Okay. So right now, what I have done is that I have converted a list. Like I can make I can store my syntax in my data structure that I'm going to use for parsing the ASTs. You've been implementing lead code problems using recursion schemes. Nice. What's recursion schemes? Like the library, this one. I think you was talking about this earlier, right? Before I went into the Haskell. When recursive functions share the same structure, e.g. pattern match on the input, and depending on the data constructor, either recur on the smaller input or terminate the recursion with the base case. Another start with a seed, something. So yeah, we do this. These functions are very similar in both cases. So we can abstract over those primitives use higher order functions like folder, right? So yeah, technically, like I have literally written the same thing, right? I'm doing the thing recursively here, updating my structure. So could probably use one of these schemes here, using F algebras to factor out the recursion from the algorithm. Yeah. Yeah, because like this can be the yeah. But I'm not going to look into how to do that because I'm like there's already too much to learn. Yeah. One of the things that I'm using in my Haskell implementation, though, like this over here is a pure function, but I've been using the effects, the effectful library. Do you use that in your code or not? Because I like as far as I understand this is easier to use than the monad transformers because I don't need to like worry about the things that much. You're currently using monad transformers. Yeah. So like, is it just because you never tried the effects, or just because when I was searching, something, effects versus transformers, Haskell. Have effect systems completely replaced the transformers? As far as I understand, what people are saying is that I don't think I choose MTL over effectful for a new project. So like, as far as I understand, like people are preferring the effects, and like I don't have a lot of experience with monad transformers, but I think I understand how they work, and I agree that they are like you need to do a bunch of like lifting. It's weird. You looked into effect, but it was overkill for what he was doing. You're basically only 1 to 2 monads in your stack, except and writer. Aren't you making a game? If you are making a game, I thought you would have a lot more monads in your stack. No? like say, take the rendering part. They're like, or like, what's the front end for your game? Is it a graphical? I don't remember. I would expect there to be more things. Is it similar to the language you have global mutation, login available everywhere, and also have exceptions? Most languages like C++ or Java are effectively programming within the context of an except plus writer. So you're saying writer because like it's the logging? I would call it just the logging instead of writing, but yes. So except is for handling the exceptions. I'm using right now the fail effect instead of like the thing, which like makes my effectful stuff to be the fail monad. So I can use like the fail, but I don't care about the order, which is like the advantage over the classic transformers. But yeah, you want like this is failing with just like strings, but you want sometimes the custom error types, I guess. I don't know, like right now I'm not using a lot of these things, right? But I think I will have more at some point. Anyway, this is how I expect my language to work, because like basically everything is going to be effectful. It's just unlike languages like C++ or Java, we are going to have to annotate. Like this is going to be in the type system. You cannot just mutate the global state, right? You will need to annotate your function with the effect that it is mutating the global state. Basically. And yeah. You don't really need any more effects in most cases. Like, don't you like have some state, though? I think one of the most useful effect, like, don't you use the state monads? You say you only use except and writer, so everything else you just write as pure function, which is like returning the new thing. Because I think it's a lot easier to do it with the state monad than, I don't know. Like, I mean, it depends. It depends. Like the thing that I have written right now, I have not done it with a state. I instead like produce a new value. Yes, but depends, I guess. State is just the base type in the monad transformer. So you have three monads then, right? You have the state, except, and you have state, you have except, and you have the writer. Like, is your state always like the same type? What if you have multiple different states? Do you never do that? You have like multiple different states that you need to maintain, and in this case, because you have like two state monads in the stack, you would need to like lift some of them and not lift some of them. With the effects, I can do that easily. When I get the state, I can annotate it with a type, which is the type of the state that I want to get. You have two monads. A monad parameterizes the base type. The state isn't a monad. That's the thing. The monad is over. Okay. So you are not using the state monad. You are returning the new state. And you are getting a state as an argument instead of using the state monad. Okay. Sure. Sure. It's like I said, like sometimes I think that makes sense. Sometimes I think it's easier to work with the state monad. Depends. We'll see more when I have more experience with Haskell, I guess. But I like the effect solution because it's basically how how my language is going to work, like I said. So yeah, I'm going to parse the AST, right? So we have a list of spent tokens, and I'm going to get the AST as a result. That's it. Like if I don't, Yeah, sure. Let's do that. Let's not do the effects for now. So when I parse, oh no. How do I what do I do about this? I'm being botted right now, and what am I supposed to do about it? Someone is spamming 1,000 follows into my channel right now. Like, am I supposed to do something about it? What am I supposed to do if my Twitch channel is being follow botted? Am I going to get an answer for that? Probably a Python enjoyer. It's still going. It's still going. Report the problem. Use the report feature on suspicious account. Am I just supposed to like click on a random person here and say report? But like I'm not going to click on everyone, obviously, right? And report everyone. Warn, timeout, ban, report. Where is the problem? The user itself. What am I supposed to report for? Search. What do you mean search? Reason. Bot. Missing. Tell us more. My channel is being botted. What am I supposed to do? Botted. This is one of the bot accounts, I guess. Submit report. All right, it's still going. It's still going. 1,500 followers. This is like second time, I think. Did Twitch ever ban the other things? Because if I go to the Twitch tracker, /Kuviman, you can see it easily. Where is it? Statistics. Where is the followers? Statistics. Are we casting yet? I'm being follow botted. Look at this. Look at this. Look at this graph over here. So this is the so the blue graph is the thing last 30 days. Is this thing working? Hello? Year 2024. Oh my god, this website is also like doesn't work. Mona transformers versus effects. Yeah, anyway, this has happened the twice. Last time they basically did this over here. That was like 400 bot accounts. And right now, I'm having like, what, 1,000 bot accounts that are following me right now? Or is it, like, it's still going, right? No, actually, I think it stopped, finally. Like, yeah, I think... would I see this thing if Twitch, like... Twitch is supposed to ban these accounts, right? They're supposed to detect it and ban them, no? Anyway. It's annoying. I just don't know what to do about it. But this time I reported one of the users. We'll see. I'm at 4,700. Yeah, that was like 3,000 followers. I can report the situation somewhere to Twitch. Like, I just clicked on a random user and reported a random user, including like the message that I am being botted there. I don't know if I can do anything else there. Somewhere else. Anyway. I can remove the bots with commander root. What do you mean commander root? Twitch tools by commander root. Follower remover. Followed between account created. Like, let's see. Account created September 16th. Account creator created September 16th. So like all of these accounts have been created on September 16th, it seems. And then they followed me today, so September 19th, right? So they are 3 days old. Kind of. So we can like filter out the users who were registered like in the last 3 days and just followed me, and we just ban all of them. Is that what I do? Block users on my behalf? Like, is this a thing? I don't know. Have you ever been botted, Devninya? Alright, let's try writing some Haskell. Once or twice. And did you delete them? Of course. No. How do I know, like, about the fact that I need to delete them? Like, do I need to do that, or is it not Twitch that is supposed to deal with this situation? Otherwise, could it count you for that? Like I'm botting myself? But if I reported one of the users to the Twitch, you found this on Reddit, but it's 3 years old. I recently got followed by a person that looked like a spam bot account, so I went to their channel to attempt to report it for botting. When I checked out their channel, they happened to be live, but on their description, they have something that was grabbing the IP of people. And I was watching their stream. The IP were then logged on by Discord bot in their private server. That's something different. Like, they got followed by a single account that looked like a bot spam account. Is the fact that I reported the thing to Twitch not enough? I'm trying to understand why someone would bot attack you. I mean, I don't know. Some people do a lot of weird shit. Anyway, I'm trying to parse the list of spent tokens into the AST. Could this be the Haskell community trying to stop kast? No, I don't think so, because the last time I was bought it was when I was not doing Haskell, right? So yeah. It may be something that like completely unrelated to what I'm doing. Maybe some person is just going over all the Twitch channels and like botting random Twitch channels. I can see that happening. Okay. Parse this into the AST. Okay. And yeah, so this also needs to have the syntax, right? So when I have the syntax, then I do this. Yes. All right, nice. So parse syntax. Is parse impl using the syntax dot root state. So I'm starting with the root state basically. Where parse impl is parse state spend token into AST like that. So we start with the root state, right? And then we go through the list of tokens trying to do things, right? Parse impl state is so I'm going to see if I am in the empty list, if I am in the end, then I want to be able to finish the state. Finish is parse state into AST. The parsing state, so parse state over here is the node in the state machine. So maybe I should rename this actually into parse state node, because get rule failed. Yeah, I cannot rename things. I cannot rename things. Finish is to do. Can I rename things if I don't have any errors? File does not exist. Yeah. Restart Haskell language server. Fail to run Cabal. Fail to run Cabal. Fail to run Cabal. Fail to run Cabal. Cannot find source for my prelude in app. Why are you trying to find the source for my prelude? I literally deleted the thing. Oh, wait, hold on. I think it's because... over here. That's why. Okay. Problems. Restart. Do you have any problems with your... what editor do you use when you're writing Haskell? Today I'm using the VS Code to see if it's better. Then the Vim. But I have a bunch of issues with my language server. Couldn't match syntax. That's root state. Okay, there we go. Now we only have the warnings. So can I now rename this from parse state into parse state node? I cannot. Like, do you ever rename anything when you were working with Haskell? If I cannot rename, renaming of an imported name is unsupported. Literally, renaming of an imported name is unsupported. If I try to rename this inside the module itself, then it's going to say explicit export list required for renaming. Explicit export list required for renaming. Why would you ever rename? Can I have the explicit export list code action or something? Just add this to avoid conflicts. Well, in order to add that, I need to rename it to the name which has the quote in the end, right? Like, because otherwise I would need to do it manually, which is very annoying. Okay, let's see what I am exporting here. Associativity, and I don't have autocompletion here for exporting. Amazing. Okay. Empty parse state export. Parse state, like why do I have the action for exporting only if I have a warning? Empty parse state actually should not be exported. That's not what I want to export. I want to export the empty syntax though. I want to export the add syntax. I want to export, like, this is not needed to be exported. This is internal stuff. The syntax needs to be exported. How do I export this? Give me the code. Annoying. Syntax. Syntax. And syntax, I'm only exporting the type. I'm not exporting the definition of the constructor here. And then parse state. Okay, now I have the autocompletion. Parse state also exporting only the type. I need to also export the syntax definition. What is syntax def? Like, wait, what? Wait, what? Syntax def colon syntax definition? What, like, where did it find the syntax def? This thing literally does not exist. It's not in scope. Why do you have the autocompletion for it? And this is not being autocompleted. Not in scope, type constructor, or class syntax definition. Okay, yeah. Anyway, so syntax definition can export everything. Syntax definition part can export everything. Associativity, yeah. Okay, this should be good, I think. Syntax.root state. I mean, okay, I guess I am exporting this. Sure. Okay, now that I have the explicit export list, can I now rename, please? Parse state node. Internal error. Renaming of an exported name is unsupported. Oh, okay. It literally says that renaming of an exported thing is unsupported. Haskell. Renaming of exported name is unsupported. Is there an issue to, like, how do you rename an identifier in a large project? You can use retry to rename. Is it like a command line utility? So, or using Haskell language server by selecting the code action unfold function when on the definition on the alias. What is this language? This is Haskell. Cannot recommend. Cannot recommend. But I'm going to continue using it anyway. You recommend kast? Yeah, kast I can recommend. But it's not ready yet, unfortunately. Oh, wait, syntax def, because like this constructor is called this. Okay, syntax definition. Do you see this? Look at this over here. I'm trying to rename like this constructor. I'm trying to rename it into something else, and what it does, it's renaming all the fields. You made functional programmers mad on Twitter. What did you say? Did you say that Bash is a functional programming language? Like I don't know about being functional. Like but the language server of Haskell is definitely not very functional. It's not functioning very well. That's what I can say. All right. So parse state is going to call parse state. No, that's what I wanted. I want to rename, and renaming needs to be done manually now. Well, I guess I can like do it with text. Parse state node. Let's see. What else did I rename by doing this? I renamed some other things. I think. Did I? Like empty parse state node, I guess. Yeah, that's okay. Yeah, I guess only the this function also was renamed by doing this. Root state node. Can I rename a field? A field can be renamed. That is nice. But it's not renaming the usages of that field, which is not very nice. Okay, and over here, I'm going to parse using the parse state. And parse state is going to contain the node plus some extra information, because that's not enough. So what is the parse state? Data parse state. This parse state, which is going to have the node, which is parse state node. And we are going to also have the like, you know, the values. There's going to be a list of values, you know. This is let's take a look at what I called this before. You love how Kuvi puts the in front of many words, like yesterday. You can pipe into the node. ASD. Or states. Last unassigned values. Hi? Hi, Orlin the Mage. Hello there. So there is assigned values to the current node. Values, like, you know, current node values, and the unassigned values is another thing. Morushana, hi. Badcop, hi. What else did I have? I had joining, must use final value, state until position start. I had a lot of things. You lost your watch streak. Yeah, I think like when I was not streaming for like a month, everybody lost their streak. He was at 13. Nigel was like at 50 or something. And he lost the streak. Could not match type parse state node with parse state. Yeah, so like over here, I need to initialize the state. Parse state node is this. Current node values is empty list. Unassigned values is empty. You're at 0 right now. Nice. I mean, you're at 1 right now because you're here, right? So there is at least one stream that you have been, that you just started watching. So it's 1, not 0. This. Now I cannot rename, and I need to rename manually. One for Lua watchers. Well, you're well. I mean, if you're like you're not indexing the things, you are counting the amount of streams that you have watched, right? So like you are currently watching your stream number 0, your stream indexing at 0, right? But the amount of streams that you have watched is not 0, it's 1, right? It's like the index and the size is different thing, you know? Like if you have a list with 1 value inside, you don't say that it's 0 values, right? The first value is as the index 0, but the amount of values is still 1. All right, over here, let's see. So parse impl. Binding state shadows the existing binding at effectful state shared. Whatever. So if it's empty, then I need to finish. Finish is current state. I need to finish parsing it into the AST node. Let's start with finishing. So if I am currently in the parse state, then first of all, there should be 0 unassigned values. Right? I also though need to finish the current node. You dislike the where thingy in Haskell? Why? What's wrong with it? I like it. It's like you can have your functions before or after. If you do it before, then you do the let in. If you do it after, then you do the where. In OCaml, we could do only one thing. Yeah, it's like about the order. You would rather write normal functions than putting them in there. Well, the thing that I'm doing here, I'm actually capturing this state. So, like, if it was a normal function, then I would need to parse it as the thing. You know, you dislike nested functions in general. Like it's not just a standalone function. It's a closure. It's capturing this thing. I'm going to make use of that later, or else I would need to like have it as an extra argument. And I'm not going to test this. I'm going to test the entire thing instead. So like I don't think there is a reason to because this is part of the implementation of this function, which is why it is not a standalone, but it is like written here, you know? Parse impulse state. So I'm going to see if this is empty, then we finish. If I finish, let's do this, right? To do. To do. Finish. So when I'm finishing, once again, what I need to do is I need to... So like in my current parse state node is this thing. This thing can be finished with a bunch of different things. Sometimes I can finish with a value, sometimes I can finish without a value. So so what I need to do is try to find something that I can finish with. You know? Yeah, Devninia likes tests a lot. It's like the entire like if you cannot test something, then it's bad, right? But yeah, I don't know. Testing the entire thing is better anyway, because that's what you're writing. You're writing the entire thing. Not every single small thing needs testing. It's going to be tested as part of the whole, because it doesn't like this function over here is not going to make sense without this whole function anyway, because it's going to call it into it recursively too. One huge benefit of test-driven development is that you think about the API before implementing this. I think that you don't do the test-driven development, but you do type-driven development, which is much better. So you think about the API by writing out the type of this function before actually writing this function, you know? And that is how you think about the API before implementing it. One huge downside of test-driven development is that it's not real. I mean, there is one person that does test-driven development, Devninja. Yeah, I have not seen anyone else do that. That's true, but parse. Okay. So I need to find the finished node. The one with as much, like, so I'm doing it also greedily here. I'm going to assign as many values from my unassigned values as possible. Let's see. So what do we have in the map? What do we have in the map? Can I iterate? Can I iterate? Fold L, fold R. Folds the values in the map using the given right associative binary operator. Like what I want is to find something that we have in the map. I think what I want is to have like two lists. Specifically this, to ask list or to desk list. Yeah. Or rather, like, in order to make it faster and not iterate over everything, do we do... I mean, I don't think it matters, because those are going to be small relatively. But is there like an operation like if I have a key, since this is ordered map, I want to find the biggest key in the map that is less than or equal to the value that I want to give it. You know, query. Let's see, look up the value in the map, but not exactly that, right? I want to find lookup lt find the largest key smaller than the given one and return the corresponding key value pair. This is what I want. Yeah. Where's the dark reader? Do I have the dark reader? There you go. How do I enable it? On. You happy? It's just like, it looks weird on some of the websites. So I don't have it usually enabled. You can see again. Let me pin to toolbar. There you go. And quickly do it. You can exclude those size easily. Yeah, maybe. Okay, so lookup less than or equal. Yeah, there we go. Less than or equal is the one that I want. All right, let's see. Data map look up less than or equal. So the key that I'm going to search for is the length of the list, which is the current state unassigned values. That's what I want. Let something be this in to do. Okay, so I'm going to look up this in the map, which is state finish, state node finish, right? No instance for. Yeah, I need to export it. I understand. But so like I actually need to export everything. Sure, associativity also. Okay, so something in this case is a maybe int, and since so this int is the amount of values that I'm going to consume. I'm using VS Code. Yeah, I was trying to use VS Code yesterday, but yesterday for some reason whenever I was like formatting my file, it took literally a minute. I have no idea what's different today, but today the language server is not being that horrible. I joined the good side, better late than never. I have been using VS Code always. Like for Rust, the Vim doesn't work well. For Haskell, it's okay. It was fine. I mean, in Haskell, I have the problem with the language server, not with the editor. It doesn't matter what editor I use. Too much. In before Kovi writes his own text editor. Hold on. The language is not ready yet. We are writing the language, then I'm writing a game engine in that language. Then I'm making a game using that game engine. Then I'm using the Haskell LSP is horrible. Yeah. Is there like anything better than the Haskell like there is literally no alternative, right? This is the best thing that I can have as my Haskell experience. It is indeed really horrible, and I'm wondering why. Like Haskell, like, is it just because like the Haskell people don't care about it? Took you ages to set up in NeoVim? No, setting up the language server in NeoVim took me literally 1 second, because all I did is I installed the Haskell tools plugin and then it's done. Setting it up was easy. Or do you like actually need to configure it for it to be usable better? Haskell people usually write on stone plates. I mean, I remember when I started with Rust, in Rust, the language server, like, there was, like, not the Rust analyzer, but, like, the Rust language server that was before the Rust analyzer. It was also horrible, but this was a long time ago, and the experience was basically like, yeah, I couldn't rename anything, I couldn't do things too, but that was a long time ago. But I did have this experience. Also, like in other languages that I tried, I had the same, like when I tried D language, it was the same. But yeah, over time I got used to the fact that Rust analyzer became actually good, and now I can, and now I think when I was trying like the TypeScript last time, the language server of the TypeScript is worse than the Rust's language server, which was weird to me, because I thought that like that should be like the best language server in existence, but it's not, for some reason. Because like isn't like the language servers like started with like, I don't know the history, no, I will not say anything, but must be an operating system issue then? What do you mean? Haskell people don't do tooling, they do math. PowerShell user here. Wait, you are using PowerShell? Are you using Linux or are you using Windows? If you are using PowerShell, when you have trouble running the TypeScript LSP, no, I didn't have trouble running the TypeScript LSP. The trouble is that the language server in TypeScript is not as good as the Rust language server. That's what I said. It's I have no trouble running it, but like one of the things that I can do, I don't know. I think I remember like some small things as like when I look at a type over here, like you see over here, this something is of type maybe. In Rust, I can click on this maybe to go to the definition like easily. In and in TypeScript, I could not do that. As like one tiny small example. Like just navigate, like the language server needs to be there for like the refactorings, like renames is the biggest refactoring that needs to be there, right? And another important role of the language server is navigating the code. So you need to be going like to the definition of this thing easily, right? And I should look at the things, I should look at what type it is, and I should be able to go to that type, you know? And I could not do that. Like I can see what it is, but I cannot go to it, you know? And that's painful, you know, because I want to take a look what this is too, right? You know? I mean, there is like buttons like go to the type definition, but this is like more work, you know? It should be easy to use. So yeah. So we have found this thing, right? Can I assign this to the thing? You know, values like final values. You know, like amount of final values that I'm going to use, and the syntax definition that I'm going to parse this thing into is that. Couldn't match expected type, maybe? Oh, yeah. This should be, yeah. Yeah, because like this is potentially failing, right? So I'm going to go this into case. No. What do we do? I think I do this into case, just this, that, and if it's nothing, then I'm going to error saying, like I can't finish, something like this. With IntelliJ keybinds, it's Control B to go to the type definition. Yes, but like it's more work. Like I want to hover, like I want to use my mouse, you know, when I'm just looking at the code. I know that there are keybinds for that. It's just more work in general. Go to like I don't want to go to definition. I want to stay at this location. I want to have this hover thing, right? And while I'm hovering here, I want to like hover again here. Like even that would be even better. You know? Screw them mouse users. Why do you say that VS Code is the light side? Why did you like do you use the Vim plugin for the so you use IntelliJ, you use the Vim plugin there? Nested hover would be wild. You mean like good? I think it would be good. Yeah, I don't think you have it. Like the only thing that I can do right now is like in my Rust I can like click to go to this. And there's like the type of the state is like is a combined type of different types. So I want to be able to click on specific things. Right? If I do this in Vim and I go to the type definition, then I have like the list opened of all the types that are like that this variable is composed of, and then I can go to the specific one. But I think it would, like with the mouse and like looking at this thing and like clicking is just much easier. NeoVim has hover too. Yeah, I know. I'm using the hover all the time. Anyway, amount of final values. Let's continue writing the code, actually. You don't think they support nested? It's the language server that does not support the nested things, I think. Like, I mean, I know that you can go into the hover thing, and you can do shit there, right? Let's see. Like this is my thing. I can hover. I can go into it. I have 1, 2, 3, 4 Google search. I can do it like I can even like do the actions here, right? I can even do the actions here. So like even if over here, like you know, if I could like go into this and like over here hover over this and then go to the definition here, that would be nice, right? Because that's what I'm talking about. That's what I can do in Rust. I didn't try to do this in Rust in Vim, but in VS Code I can do that. At least like go into. It's not like nested hovers, but like go into the hover and then click on the link, basically. Amount of final values, syntax definition. Okay, so I know the amount of final values that I'm going to do. So now what I want to do is I want to I want to consume this final value, so I want to like split my list into two lists. The first amount and then the rest. Is there a function like that? Data list. This autocompletion is not from the data list. When I hover on this says AST. Very bad. You barely use LSP anymore? Because there is no bash LSP. Are you going to wait? Is there a language server for bash? Bash language server? There is. Do you use it? Is there a bad cop in the contributors here? Control F bad cop. No, I don't see you here. Never tried it. You bet it's bad. Yeah, just like the bash itself. Okay, what I want is to, let's see, is there like a Hugel? No, is there like an extension for Hugel in VS Code? Hugel VS Code, look at this. Haskell Hugel search in VS Code. Let's install. Haskell Spotlight. Search and package Hugel and more soon. Which one is more popular? This one has 87 downloads. This one has 3,000 downloads. 004 preview. I don't know. Let's do the Hugel. Features. Press Shift Alt H. Shift Alt H. Shift Alt H. And I want to Hugel here. So what I want is an int, a list of A's, and this should give me a tuple of A and A. You know? Prelude, split at. There you go. That's exactly what I wanted. So it's called split at. Split at amount of final values. I'm splitting the currently unassigned values. Oh shit, this is bad. Qualified AST as state. What? No. Wait, what? Import qualified AST as state? I'm importing the module itself from itself? Is that even possible? I don't know. The language server did something. So I'm doing something like final values and arrest unassigned values is this split at ambiguous occurrence split at, because it could refer to the data map split at. Okay, let's see. I can use prelude hiding other imports. This is what I want, right? So this is going to hide this from the data map. Yeah, nice. Maybe you should write a bash parser. What for? Variable not in scope. By the way, can I this is another thing that I don't like in Haskell. Like, I really don't like the fact that the pipe is an ampersand. I really would like to do this. Okay, I think I can do this easily, right? Like, I can define my own pipe like this and just say that it's that, you know, in my utils over here. Let's see, how do I define my own functions, my own operators? Haskell define operator. How to create an operator in Haskell. Function A with symbols have a different syntax than those without. So I need to just do this. And then how do I define the precedence? Do I not need to define the precedence? So this is a thing which takes the A and then function A into B and returns B, right? That's what I want. So then I say that args into function is equal to function args, right? That's easy. Defined but not used, and then I want to export it. And then I want like the precedence, right? And the associativity is important thing to define for these things. If I don't define them, there is like some default, or this is equal to that. Yeah, I can do this. But like, I don't know. I just think this is more clear to me when I'm going to read my own code, because like the ampersand is like, I don't even know why they chose it. Why did they choose ampersand? No idea. And similarly to this, by the way, I want to define the left pipe. The left pipe is called $, which also I have no idea why they chose. So if I have the function a into b, and then I have the a, then it gives me the b, right? So so function, and then the args is function args, similarly to that, right? You know, why did they choose $? No idea. Why is pipe operator a $, in Haskell? Is Haskell $, operator and F-shar's backwards pipe? Like, is there a reason they made it a $? I have no idea. Or did they just choose a random symbol that was not used for anything else in code, and then like that happened to be a $sign? No idea. Haskell define operators. Set priority. Haskell typing priority operators over functions. Yeah, you say this infix left associative priority 9, right? Something like this. So I need to take a look at the Haskell. Let me see. $. Is it like is the Hugel extension doing the online Hugel? I cannot even go to this. Like, what? Hugel. Just watched curl author on Twitch. And also, why is Hugel so slow? $. Error status 0, undefined. Amazing. I want to like go to the source here, because like yeah, there you go. Infix R0, right? Infix R0. There's a $? Exclamation mark. What does it mean? It's just doing the strictness, I guess, instead of laziness. So we say infix R 0 that, right? That's how we do it. And then for the other one, I want to find the this. You wish there were more programmers here. Is now making rural. So I want to see the infix L1. Okay, so the priority of the ampersand is actually higher than the priority of the of this. So like the pipes. Okay. Sure. I'm just going to like match so that I can use both. One fix R1 this pipe. There you go. There's a dashboard about curl software development history. Nice. No idea what it means. The history. Okay. Let's continue. Final values. Arrest and assign values. By the way, what does split add does? Split add n access returns a tuple where the first element is the prefix of length n. What if there is less than n elements? What is going to happen? Are we going to have an error? It doesn't really... Split at -1. Okay, you can have negative numbers. Split at 0, split at 4. Okay, okay. Sure. No errors, but that's fine. That's fine. Okay, so this is the final values that are going to go into the thing. Right? And then so the value, so the value that I'm going to have is going to be AST node. The is going to be a complex AST node where I have the definition, which is this syntax definition, right? Which I can just call definition, I guess. Internal error. Internal error. Definition. The values. The values is a tuple. Is a tuple. So over here, I need to so values is, let's see, collect values for this definition, and I want to collect the state current node values plus the final values. That's what we are collecting. So like all of these are going into the current syntax definition. Okay. Okay. Collect values. Collect values. Let's see. Collect values is the syntax definition into list of values, which is in this case the AST values, and then it gives me the tuple. All right. Let's implement this. This should be easy to implement. Collect values definition is case and I guess we like start okay is collect values impl. You wish you had software to see it growing like that? I mean, you want to just construct this graph? There are some graphs, like if you have a GitHub, then you can see some things already, right? Insights, it's called. Contributors. Something like this. There is some graphs here. This is my game engine. I have written 100,000 lines of code. Over 900 commits. Nice. And Nerdsel did 3 lines of code and deleted 3 lines of code. Good job, Nerdsel. So we start with an empty tuple, right? Tuple. Expected at type, but tuple has kindness. Yeah, so if we have tuple with ASTs, right? Okay. And then I say empty tuple. Tuple is tuple A. I'm going to say empty tuple is tuple. Unnamed is empty list, and named is data map empty. Right? It's crazy how far things went with your own programming language. Next streams, Haskell was too limiting, switched to Lisp. I think if I am going to be done with Haskell, I'm going back to Rust. The yeah, like Lisp. I don't think is going to happen because at least like most of the Lisps are dynamically typed, and I don't want to write my program in dynamically typed language at all. There is a couple of statically typed Lisps, but I don't know. I don't know if I'm like willing to go there anyway. Idris when? I mean, yeah, trying Idris is would be really nice. Yes, I agree. So like yeah. But I don't think I'm going to rewrite the kast into Idris. We'll have to find some other project to work on if I want to try Idris. You only have one relatively used gem. The number of reports and contributors is too close to 0 to graph it. All right, where collect values impl is. Let's write the type here. The type is a tuple of ASTs into list of ASTs. And I also want a list of syntax definition parts. And this like populates this tuple further. So I want to start with definition parts like that. Collect values impl. So this is the current state that I'm going to see. If the current syntax definition part, is a keyword, because I'm collecting the values right now, I don't care about the keywords. So in this case, I just collect values impl current rest right. I just go for the rest. If it's an empty list, so I have went through the entire thing, then it means that the list of values must be empty. So I'm going to see now the list of values. If it's empty, then I just return the current one. If it's anything else, then I'm going to error saying that too many values for syntax definition. All right. Then if I have an unnamed value to the rest, then I'm going to collect values. You mentioned your language is translated to JavaScript. I'm wondering if you could translate it in a more useful language like TCL. You should be able to translate it into any language you want. The JavaScript is like just the target that I'm going to have as my first target, because it's the easiest thing to target in my opinion. TCL pronounced tickle. Is it more useful than JavaScript? How do you, like, why is it more useful than JavaScript? Can I translate to Bash? I think we can translate to Bash too. But I don't know, like, a Bash might be, like we can at least, like, translate the subset of it to Bash. Bash might be, like, lacking some features. Yeah, but why is it more powerful than JavaScript? Why, more useful than JavaScript? Why would it be more useful? I mean, Bash lacking features? Yeah, it's true. I mean, yeah, like if you want to translate it to pure Bash, like if you're not allowed to use anything outside of Bash, like normal command line utilities, because that's how you're supposed to use Bash anyway, right? Because TCL is implemented just in functions, all the syntax in CTL is just functions. And why is it better? Let values impl. So over here, I'm going to insert the new stuff. Right? So I'm going to make the tuple where unnamed fields is the current unnamed fields plus the top value. So I'm going to actually case here if I have the xs, I guess. If it's empty, then I do the error. Not enough values for syntax definition. If it's this, then I collect values impl tuples named plus x. Unnamed is the current unnamed. I mean, I can just so like I use the record update syntax, right? So instead of this, I say current like this, and then I do the rest access. There you go. This should work. And then in case we have a named name into the rest, then it's very similar, but in this case I am naming a field. So named things is a data map insert. I insert the name with the value of x into the current named, right? Like this. And then I go and parse the rest. Okay, there you go. Collect values, impl definition parts, empty tuple. I go empty tuple definition parts. Because the entire language will work out of the box, you just translate your language to TCL functions. Is there anything difficult with the syntax of your language? Does it require a lot of static types or something? Compared to other languages like Python, JavaScript? The entire language would work out of the box. I don't understand, like, because if I compile to JavaScript, then JavaScript also works out of the box. I don't see the difference. I don't see what you're saying. The is there anything difficult about the syntax of my language? The syntax does not require static types. Syntax is the syntax. The static types is about not the syntax, but the semantics, right? But yeah, we are making a statically typed language. It's going to be a strong static typed language with the effect system and everything. Just make your language in LLVM, it will work out of the box. I don't understand what it all means. What does working out of the box means? Just compile to machine box, to machine code, it will work out of the literal box. Okay, this is me collecting values. Continue. over here. Defined by not use final values. It's literally used over here. It's this thing that is not being used, right? Maybe that LLVM has many backends. I can also compile to C, and then C can be then compiled using LLVM to have even more backends, because I will be able to use not only LLVM, but also the GNU compiler, which targets even more things. So like technically transpiling into C will allow me to have more targets than LLVM. You could target GVM, that's a good one. Yeah, we will be able to run on the million devices, right? Because Java is running. No, not million, billion devices, right? You mean just because you compile to JavaScript, you don't have any libraries you can use? TCL is a glue language with lots of functionality built into the language? Maybe I don't understand what TCL is. What is the glue functionality? Because I'm compiling to JavaScript, I will be able to have the access to the JavaScript ecosystem, which is the functionality that I don't need to implement myself, right? And if I target something like C, then I would need to either use like the C libraries, which are a lot harder to use. And there is a lot of like more low level, like C is more low level than JavaScript, so there's a lot more work to like transpile. Right? I could also transpile directly to assembly, which will be even more work, or use like LLVM, which is also more work than transpiling to JavaScript because it's more low level. I'm not sure how, I don't know. Like, can I use TCL to compile TCL to JavaScript then, or what? JavaScript only has browser functionality? That's not true. There is no general purpose libraries for JavaScript? That's not true. That's not true. Do you know about the existence of Node.js? Do you know what this is? Run JavaScript everywhere. JavaScript is not only a browser language. People write backends and frontends in JavaScript. People write everything in it. The GitHub Actions. Have you ever tried GitHub Actions? This is built with JavaScript. Like the API is JavaScript. If you want to build your own custom GitHub action, right? That's used for CI. JavaScript is a general purpose language. What am I doing here? So I have the value. So the value is this. This is collecting values. Yes. Okay. So the only thing... Definition... Wait, hold on. Complex. Tuple ASD. Yeah, so like over here, I need to also have like the span information, right? JavaScript is the new Java confirmed node better than GVM. I mean, there is more code. I don't know. I don't know about these statistics, but I think JavaScript is much more used language than Java. So in a sense, yes. That's the reason I'm targeting it, because it can run everywhere. It can run in the browser, it can run outside of the browser, it can run everywhere. That's the reason I'm choosing it. The main reason. You respect JVM more though, but the Java, yeah, but the Java virtual machine cannot run in the browsers, not anymore. I mean, can it? Maybe if you compile, maybe like there is implementation that you gotta like compile to the WASM or some shit. Maybe you can run Java in browser. Okay, so over here, data. I need to like in my when I'm parsing my AST, this data that I am associating with every single AST node is the span information. It's the span information for to know where the where do I start, where do I end, and everything. You know. Yeah. So data is span of values values like this is the values like of this node, you know. Child values, I guess. This is the child values. I don't need the brackets in this case, right? And then span of values is so I have the list of values and this gives me the span, right? So span of values is span That's not true. That's not true because the values is not enough. The values is actually not enough because we might have some keywords too, right? The keywords are not counted in the values here. So I need to, I think I need in the parsing state, know where did I start. So start position is position. Start position. Is position. What if there is no spent tokens then? Well, I guess yes, start position is nothing because like I'm going to initialize the start position as soon as I as soon as I consume at least one token, right? Start position is maybe position, right? This is for knowing the import reader. Yeah. So this is not the span of values. This needs to be from just state start position. So this is the span that I'm making. Start is this span. Add span to the list of lexer. Add span to the import list of lexer. Sure. So then from just I need to import data maybe. Sure. Then I also need to know what the end is. The end in this span is going to be the current position, right? State dot current position, I think. Which means that I need to know not only the start position, but also I need to know the current position, right? What would be the current position at the very beginning? Maybe it's also going to be nothing. It's going to be initialized only after I consume at least one token. Maybe position. Also from just, and then the file name. File name. Hello, Nigel. File name is like similarly state file name. Maybe. File name is nothing. File name is maybe string. Okay. Now we just have the unused values. Okay, sure. So I think this is me constructing the one single AST node out of the values after we have them. And then where's first? Is it gone? I think if it's gone, it means that we have had the first, second, and third already. Yeah, because Bad Cop redeemed the third. Bad Cop was third. Okay, so now that I have the values, there's still some unassigned values that are potentially there. So I think I'm going to actually see if there is... I mean, I'm just going to continue parsing, I think, right? You know, I'm going to call the parse impl on. So the parse state, I'm going to start back at the root. So syntax root state node, which is this. This line is a bug, but it's okay. Which one? Anywhere? All right. It'll be great when you forget. We'll see. Let's see. Let's see here. New state. New state is parse state. New state is this. There we go. Or simple new state. And over here, parse error, possibly incorrect indentation or mismatched brackets. Oh shit! Now I need to take a look at the indentation. This is the annoying part about. This is all the lets. Oh, it's in. It's because it's in not to do, but in parse simple. There we go. This is what I want. Good mesh type. Imagine if that line turns out to be the bug. It's going to be okay. It's okay. So I'm going to start parse simple using the new state, which needs to be over here. Ah, shit. Why is it based on indentation? New state, and then I need to parse. Like, since this is finishing. Wait. Wait. Like shouldn't this return the like the values that I have not assigned anywhere? How did I do this before? Let's see. This code is not very trivial here. Finish, it's finish result. Yeah, I think finish result is like is the AST itself plus the remaining unassigned values. Yeah, that's true. That's true. That's true. So finish is finish result. Data finish result is finish result. We don't have like anonymous records in Haskell, right? We don't. So the value is the AST, and unassigned values is the is just the list. ASTs again. Yes. Finish result. So when I'm finishing, I am returning finish result where the value is this, and this is not the rest unassigned values. I'm just going to call this just like there, unassigned values. Unassigned values. There you go. Now this is done. Shadows the existing binding. Our state. I cannot rename anything. The language server does not work. Bar simple. Okay, so if this is the end of the a file, right, of what I'm parsing, then we just need to finish. And but this is only finishing like one thing. Let's see. Let finish result be that in so I will return the value, right? But I'm going to, do they not have the warning that I'm not using the other field from here? So I'm going to say something like case unassigned values of empty list, then I'd return the value, and if it is anything else, then I say that there is still unassigned values. I think this is to do, like I need to actually like do some more stuff here. I'll just say to do here. Okay, and then if we actually have a token, and if we actually have a token, then I should see if I can like advance my state, right? So we are going to construct the edge. Let's see. So edge is the edge. To do. The edge is not exported from syntax. Edge. The keyword that I'm trying to go through is the current token, the raw token, right? The raw token. Wait, what? Token is a spend token. Spend token has token inside. Fields of edge. Not no instance of GHC records has field token. Spend token. Arising from selecting the field token in the first argument of raw, namely token. The records is the most annoying thing of Haskell, I think. What is the extensions that I have? Like duplicate record fields. Is that not like enough? The amount of values anyway is the length of state unassigned. Oh wait, I want to like go through like as much as possible. Yeah. That's what I want here. So yeah, I want to like consume as many as I can. Wait, can I not consume all of them though? I don't think I can. How do I fix this error? No instance for GHC records has field. But it definitely has the field. It's because I did not import it. I know why. I know why this error message is really bad. It's because I did not import the entire thing. What if I import the entire thing? Then I no longer have the issue. So this is the edge that I'm trying to go through. So I'm going to see next state, next node, I guess, is data map find. It's not called find, right? It's a query. Lookup. It's called lookup. What's the lookup? For all k into map into maybe a. Yeah, it's exactly what I want. So we look up the edge in current state node. Next, because I'm trying to go next. Next node. Can I do it inside the let? So this should be like maybe parse state node, right? Yeah, I can have these things. Nice. So if this is the next node, it is potentially not there, which means that I cannot continue with this keyword, right? But if I can, then I should. Like there's also priorities that are going to happen. I forgot about those, right? So when I have the edge, once again, I should have the priority. right? But the priority is not stored on the edge itself. It's stored in the node, I think. You did multiple queries? Nice. You think? I'm thinking if I should just like look into my OCaml implementation and do one-to-one. This is the most complex code in the kast language. Like the syntax parsing is the hardest thing. But like this also looks not very nice. But yeah, it's 500 lines of code. I mean 400, I guess, because this is where the parsing actually starts. And then there's also, and this is like the parsing of the syntax, because syntax is the only hard-coded syntax, defining new syntaxes. Okay. Yeah, and this is called parse until because of the priorities. Parse state should know about the priority that I am parsing until. Yes. Until is a priority. It is priority with associativity, I think, together. Last translated values, joining, must use final value, state until, position, start, syntax. Oof. Okay. So yeah, there's a thing that's missing here. I have the priority and associativity in the syntax definition, but not when I construct this, I lose the information basically. But I should have it here. I think it's in the parse state node. I should know like the I'm going to call it the binding power. Binding power. Data binding power. So this thing has the priority, which is a float, and it also has the associativity, which is associativity. And this thing should derive the ord, which means that the associativity associativity must also derive the ord. Right? No, I don't think so, actually. Hold on. I'm not going to. I think that's not right. So the root node is going to have like the associate the binding power is going to be like whatever. Priority is float. Is there like a minimum float or something? Minus float. X16, X4, X8. It's going to have 0, and associativity is left. Effects. I couldn't be right with that. What are you talking about? The are you talking about the visual effects that I have when I'm typing my code, the screen shake and the particles? Or are you talking about the fact that I'm using the effect system over here? Are you talking about the F monad? Left. Ambiguous occurrence to left. Can I say associativity dot left? Data constructor is not in scope, associativity left. How do I make sure that, how do I construct this thing? Is there no, or do I say like left colon associativity? Can I do that? It's still ambiguous. How do I make it unambiguous? Because there's the prelude left. Because it's the either type, right? Is there no way for me to disambiguate without hiding this? Visual effects when I'm typing. I've turned those to a minimum, but I don't know. I like the visual effects. I like the visual effects. It's a little funny thing to distract me while I'm working. Haskell, disambiguate, data constructor. Why are data constructors of the same name disallowed in different type constructors? Because data constructor just functions. Because Haskell is stupid. That's why. I'm just going to hide the prelude. Right? That's what we want to do. Sure. It just means that like I need to come up with like different names every time, which is very annoying. So over here, I will say that the binding power is definition dot bind dot it's binding power. Priority is definition priority, and associativity is definition associativity. Like that. Similarly, wait, this is finish. Wait, hold on. What am I doing here? Insert definition. It's an empty. No. I'm just going to next is state next. Binding power is state binding power. Like, I'm not changing it. That's what's happening. Because I don't need to change it. But over here, I also don't need to change it. The thing that I need is over here, the default state. Empty par state, no, this should have the binding power as an argument. So over here, when I'm initializing that, I need the binding power where priority is definition priority and associativity is like this is the binding, like this is the power, you know, this is the power. Let's see, let power is that, you know, and let's not do the prom. Maybe let me insert definition impl into this. Like, you know, I'm going to case current of nothing, then I'm going to create the empty sparse node of power. If it's just current, then we return the current, right, like this. But I need to assert that case, like if current binding power is equal to the power, then we return it. Otherwise, I need to throw an error. Different binding power, something like that. So then I'm for the binding power, and I need to have equality. I don't care too much about the thing, the order yet. Rs impl. Okay, so here we go. Here's the edge, and here's the next node, right? So the next node, because so this should be called parse until once again, right? I cannot rename things. Amazing. Okay, parse until. And I'm supposed to parse until the specific power. Until is the binding. Till is binding power. Until is nothing, actually. Like, we can make this be an optional. Until is maybe binding. That's what I want. Not in scope, type of class constructor binding power, because I need to export this here. Okay. Until nothing, which means that I can parse until the very end. I don't need to stop. I don't need to stop. I missed the typo. Different. Different. Is that how you spell it? Different. Binding power. Do you actually understand what I'm writing? Though, it's nice that you have catched the typo. Let me try to explain a little bit what I'm writing. I'm going to use Paint for that. So we have in the language the syntax, which we can define ourselves. For example, let's say that I have the if like condition, and then I say then something, and then I have else something else, you know? This is one of the syntax that can happen in the language. Then there's another syntax which is just if underscore if something, then something else, like, you know, without the else branch, because we just use this for like the effects and everything, you know? So these are the two different syntaxes. The way I'm doing this is I like, let's say that this is the only two things that can happen in the language, right? So what I'm doing is I'm constructing the state machine, the graph, right? Where, so we have like the root, and then if I go and if I see the if in my code, I will go into this node, and then if I then see the then keyword with a value before it, then I go into a different node, and then from here we can go two ways. We can either see the we can either like just like finish. I don't know. Let's do this, the black circle as the finish node. So like this is how I can finish parsing the current thing. And if I have the else with if I have the else, then I go. If we have an else with a value before it, this is like the then branch. Then I go into a different node, and then from this node I can actually like finish having like another value as like the value of the else branch. You know, I'm constructing a graph like this. So now I need to go through this graph to actually like parse it, you know. And then when like this underscore is like basically can be like parsed into something else, for example, into another if then else inside here, like based on the priorities, you know, kind of that thing. So like I think I have like this graph already. So an edge in this graph is the keyword plus the plus potentially we have a value before the keyword, or maybe multiple values, or maybe no values, because like sometimes like I just have like a keyword, like for example over here the if, we don't have a value before the if, but if there was like something else like a plus b, right, we have a keyword plus with a value before that, you know. So like the edge in this graph is the keyword plus the plus potentially a value before the keyword. And then whenever I want to finish parsing a certain like syntactic construction, this also potentially, like for finishing, we potentially have some values in the end, you know, because some of the syntactic constructs, they end without a value, and some of them they end with a value, you know. So yeah, something like this is what I'm trying to do. And then we also have like priorities, and as far as I know, this is something like a pret parser, right? But it's not a fixed syntax; it's a dynamic syntax that I'm making. All right, that's the short version of what I'm doing here, in case anyone was interested. Rewriting OCaml code in Haskell, awesome. Yes. Yeah. Like I could write it one-to-one, but I'm trying to like do it from scratch here, which makes me think a little bit more. The OCaml code is over here. We have this 500 lines of code that I need to translate. Soon to be rewriting it in kast. Yeah, hopefully sooner than later. Because Haskell is also annoying, to be honest. But I want to do a little more of it, just so that I understand the language better. Like the records are very annoying, the language server is very bad. Well, I mean, if I will be rewriting it in the language itself, in the kast, then I would have no language server. And unless I write the language server before rewriting it in kast, you know? I wonder how hard it will be to make the language server. Like, can I not just like use my like compiler as a language server like somehow? Because it's going to do the same work, right? I just need to like store the information about the things, and then when I'm hovering on things, when I'm renaming things, I like know where the identifier is used, so I know all the places. I like writing kast LSP in Rust before writing kast in kast. I think the way the like I have not thought about it too much, but I think the language server and the compiler itself is going to be the same thing, or at least like there is a lot of like shared code. It still needs to like parse the thing, right? And in order to parse, I need to like almost like evaluate some things, you know, because of the macros and shit. So I think the compiler and the LSP, the interpreter, it's all the same thing. So the only reason it will happen in Rust is if I drop Haskell and rewrite everything in Rust, which may happen. Okay, over here we have the next node. Okay. So there's two things. There's two things. Let's case the next node. And the next node is either just next node or nothing. Right? And if it is just next node, I forgot the auth, of course. Yes. If it's just next node, then there is also like it does not mean that I actually am going to continue parsing. I'm only going to do this if it should continue from our current state. So like this is my current state, if I should continue from this state into the next node, kind of thing. So like, let's see, should continue. There is a parse state into the parse state node into boolean, and this is fuck. Why am I importing something here? Should continue state, and next node is basically the priority must be more than is there a function that's like compare or ordering? Yeah, this is what I want. I want to compare state until priority with next node binding power priority, and this can be like nothing, right? Which means that I'm going to map maybe. No, not map maybe. How do I map a maybe? Google. So I want to have a function from A to B, and I have maybe A, and then it gives me a maybe B, right? It's called fmap, right? So I'm going to fmap. I'm going to fmap priority for the state until. There you go. Ambiguous occurs for priority. Yeah, because like, yeah, power into power priority. Something like this. And fmap is just this. That's just the same syntax. Anyway, so I'm comparing this, and then I am passing the result into a case. Compare gives me the ordering, which is probably like the less, right? And other things. No, not in scope, less. So what is the ordering? What is the ordering? How do I know? How do I like click on this? No, I cannot. Okay, okay. I cannot go to the compare definition too. Can I Google the ordering? Prelude data ordering. Data ordering. Oh, it's LT, AC, and GT. Of course, it's like just two things instead of like actually spelling things out. Okay, so if so this is me comparing my the priority that I want to parse until with the priority of the next node. The next node must be, I guess I want to like swap the order here. I'm comparing the next to the until, and if it's greater than, then I will return true because I will continue into the next node from this state. If it is less than, then I will not continue, and if it is equal, then it depends on the associativity, because if the priority is the same, like let's see. So like if we have like A plus B plus C, right? When I have the when I have like this plus, the priority is the same as like for this operation, right? But I should finish this first. First because it's a left associative operation. So if the priorities are equal, then I should continue only if the associativity is right. Can I have these can I have one of the associativity to be right and one of them left? I don't think this can happen. Let me see. How did I write this before? Did I also call it should continue? I think so. Should continue with. Until associativity. Yeah. Associativity. I guess I just do a maybe. True. Power associativity is equal to the right of the state until. Syntax right. Okay. This looks nice. Pattern matches are not exhausted. So like basically, couldn't match expect type parse state node with actual type maybe parse state node, because I want over here to next node with a quote. Maybe I should instead rename this next node into like maybe next node. Of course, the renaming doesn't work. Let's just do it manually. Maybe next node, and over here, then I will not do that. There you go. So we have, sometimes we have the next node. I guess I just do underscore, because like if I don't continue, then it's the same as having like no next node, basically. There we go. So I have the next node that I should continue with. In this case, next node that I should continue with, in this case, I want to say, I just need to like go into this node, right? Since this is the edge, all of the unassigned values are going into the current node values, right? And I'm going to then continue parsing. I'm going to parse until the new parse state. And I'm going to, so like, I'm going to like have the new state here, right? New state is something, you know, I mean, I'm going to parse until this new state. I'm going to parse the rest of the tokens, and that's it, right? So now we just need to know what is the new state. New state shadows the existing binding. You know what? I think I'm okay with shadowing. I don't know. Let's call it next state. Fine. Whatever. Parse state. No, I don't want to disable. I want to fill the fields, but I cannot do that. Node is next node. Okay, that is easy. Start position is the same as the start position, but maybe let's see. Maybe the default value is going to be token span start. The start position now is going to be just, in case I did not have a start, I will initialize it to the start of the current token. Otherwise, if we had, then we just do the ID. Maybe there is like a better function for this. So what I'm searching for is a into maybe a into a, right? Is it not found or what? No, there you go. From maybe is what I want. So it's not maybe. I want a from maybe token start and state dot start position. There you go. Next, the next field is the current position. Current position is going to be just token span end. The file name is just token span file name. All right. The current node values is state current node values. I'm going to append the new values the state unassigned values here, because I'm going to assign all of those values. I have traversed through the edge here, right? Sometimes I want to like use not all of the values though, right? I think. But anyway, unassigned values, since I have assigned all of them, is going to be empty now. Hello, Brainoid. Maybe I should play Brainoid's game for a little bit before continuing, because this is hard. I think wasn't I playing your game last time when I was writing literally the same code but in OCaml? Because this code is hard. Until is state until. I think it was literally the same code. I'm rewriting it. Maybe the problem is your games. Wait, well, I mean, did end up writing the code? The code is just I mean, like, this is just like the hardest part of the language implementation, I think, at least right now. Okay. If I should not continue, then you're trying to make your game multiplayer, like the one for the Brekkies game jam. See, Ash, how am I? I am doing great. How are you? Didn't have the Kubi courage to make it multiplayer doing the gem. All right. Disable name shadowing warnings. Disable. I have disabled it. Token rest. Okay, over here, this to do. We also have this to do. Okay, so unassigned values. So I have some unassigned values. Even although it's the end. To be fair, it's already a big game without multiplayer. So I have the value and I have the unassigned values. If in case I have more unassigned values, then I think I need to start parsing. Until parse until for state is node is syntax root node state. Parse until using the new state. And parsing nothing. But this new state needs to be with unassigned values. Being unassigned values plus the value, because that's the final one. I also am pretty sure that I did a bug here, because the record update state, this will be supported by the X duplicate field records in the future releases. This will not be supported because it's ambiguous. The record update new state is ambiguous. What is ambiguous here? Nothing is ambiguous here. Anyways, you implemented the seed for level generation is properly replicated among clients, replicated doors and other iterative objects, replicate enemies to some degree, and it needs more work, and since it's scope multiplayer, you plan to make it host-based, not server. Yeah, makes sense, makes sense. Do you like plan to release it, like, so, or are you just making a small post-gem version? Or do you want to put it on the Steam? What about your card game? You wanted to release that, right? You know what I'm thinking right now? I should stop doing Haskell. I think this over here is enough for me to drop Haskell. This stuff, like the fact that the records are this bad, is enough for me to drop Haskell and go back to Rust. This, the language server, the yeah, like the name collisions. I cannot have multiple data structures with the same names of the constructors. The names with the same the fields with the same names is really annoying. Rust is always better. I mean, not always. Technically, Haskell has like better type system, but other than the type system, everything else is worse. In my opinion. Yeah. And the type system is like slightly better. It's not even like a lot better, I think. I mean, it depends. I didn't really like do, I don't know. Like if I really need to do something like really complex with types. Like for example, I can have the checked effects, right? In Rust, I can easily. Haskell is less pedantic with closures. Well, yeah, because it's a garbage collected language, similar to OCaml, right? I can have I can have I can have local like closures, mutually recursive and everything, which is not possible in Rust, right? Yeah. That's true. Like sometimes you need to be very verbose in Rust because of that. Instead of doing closures, you just do the methods on a struct, and but yeah, but then you like need to construct a struct itself. It's like, yeah. But I don't think I have been in that situation like a lot of the times. Like it happens sometimes that I need it, that I want to have that, but it's not that often. Let's see. Let's see what you think. Rust, Haskell, or Camel? Question mark. There's a poll. All right. I mean, we can just continue. We can go back to OCaml. We can write more OCaml because, like, the OCaml, we have some implementation of the language which we can continue building on instead of using Haskell here, or I can continue using more Haskell, or I can rewrite from scratch in Rust, which should not be as slow and annoying as it is in Haskell right now. Which one would I prefer? I don't think I want to continue OCaml. I don't think I want that. OCaml is annoying. You don't want to see 100 different languages? You want me to stick with Rust? You only want to see kast and Rust? Okay. Well, I mean, the reason to try out different languages though is because because in order to make a language, we need to try languages, right? Is there some weird way to use records in Haskell that a veteran would tell you? What do you mean weird way? There is it's like, you know, Brainoid is similar to how if I'm making my own game engine, I should probably like look more into other engines and how they do shit. So I should still try Godot sometimes. That's still on my plans. You recently came to know the basics of Rust were implemented in OCaml, and then the things were made and tested with Rust. Yeah. It was like Rust is made with Rust. You can do the same. I mean, yeah, I mean, eventually I'm going to rewrite the language in itself, but like, it's probably not going to happen very soon. Something unexpected that makes things easier. Well, I thought that like these extensions would help me, you know, because like you have duplicate record fields extension, because by default you cannot even. I'm not 3 years old. You've seen enough languages. Move on. I mean, there is I don't know. There is some ideas that I have not tried in some of the languages. But yeah, by default in Haskell, you cannot have the duplicate record fields at all. But using this extension, I can at least have them, but then it still is annoying. There's a lot of value in learning Haskell, but like, I mean, technically I know Haskell. It's just like very annoying language to write, in my opinion. You know, like I have done this. Like I did the lexing. I use the monads here. Like I use the effects from the effectful library. I tried the monad transformers too. Like I think I understand Haskell enough. I have not written my own type classes here, but that is easy. This is literally the same as in Rust. Most annoying with records. So yeah, I mean, here's the list of the annoying things. It's the records. It's the it's not only the like the records is like it's because like they like for every field they make a function which is like the getter of this field, and like and you cannot have the same function for like I wish there was just this function was not generated and I would only use the dot syntax. I'm already using the dot syntax by using the overloaded record dot, right? This is the extension that allows that. Is there an extension that removes the function generation for the getter? Because like I don't need it. I think that's what is like hurting the language here. That's and like for the same reason, kind of, I don't like the fact that I cannot have multiple data structures with the same constructor name. Similarly to how I cannot have multiple records with the same field names, I cannot have multiple data structures with the same constructor names because of the same reasons, kind of. I wish it was based on like it should be. I don't know. Like, I mean, there's value to it just being a function, but I don't know. You just use MTL. It's not bad enough that I can bother with effect and stuff. Well, as far as I understand, like I mean, you obviously have written more Haskell than I have, right? Because you use it, you say. But there is a lot of unnecessary lifting that needs to happen when you are writing with the MTL. Of like when you use the monad transformer stuff. Monad transformer is a little bit annoying. In the effect system, you don't care about the order because I don't care about the order of the like in which the stack of the monads is composed. You know, all I care about is that inside this function, I want to do the reading and I want to potentially like fail here, right? Maybe I will do like some other stuff. This is like the state monad, right? I don't really care about the order here when writing this. Use effect systems in Scala a lot. This is what you use at work. Yeah. So like the effect systems are, I think, much easier to work with than like the monads directly. That's what I plan to have in my language instead. So you're like always so you will have like you will be able to annotate your functions with the effects instead of doing monads. Because like sometimes like if I have a pure functions are not that useful anyway, because like at some point I will want to refactor my pure function in order to have logging, and if I want to have logging, then I need to rewrite it to be a monadic like function anyway. Because I will now be inside the monad that allows me to do the logging, right? So like everything is like this anyway. You'd rather look into algebraic effect handlers like in OCaml? Yes. But like is the effect system in Scala different than than in OCaml? I did not try Scala, but I thought it's like the same. The effect system in Scala, like it is like in OCaml. In OCaml, like yeah, I did not use the effect system in OCaml. It's implemented as a library. I think in the next OCaml version they are going to they were going to like have some syntax for the effects. So they're having effect syntax. Is that it? I've been experimenting. I've seen somewhere that they are going to have like special syntax for handling the effects instead of just making it a library. I've seen it somewhere. Plus effect syntax. There's like improvements that happening there. Not sure if I can find it. This example used the new effect syntax introduced in OCaml 5.3. Yeah, in OCaml 5.3, which is like very recent, right? I think I was using the 5.2 when I was writing the thing. Mutable state. Module type state. Functor. This looks like the old stuff, no? Scala does not have that yet, but it will have in the future. The new system being developed for Scala is really interesting. It also allows for tracking capability lifetimes. It has two main libraries, kast effect and ZIO, both similar to effectful in Haskell. Scala. So Scala has these like contextual abstractions. You use this a lot, since we have a Scala person in chat. The way the effect system is working on top of the contextual abstractions, right? Which is basically like implicit arguments, which is the same way as I am planning to do this. So this is not only used for effects, but including the effects. We have one person who voted for Rust, one for Haskell, and one for Camel. Okay. Now I have to choose myself. Scala kast effect. Very nice effect system. Kast effect. Provides lightweight fibers for asynchronous, highly concurrent applications. Pure asynchronous runtime for Scala. Let's see. Def slip print. Word this, that. Delay random between this. Underscore IO slip. So this is like running the if I don't know the syntax. Is this does this mean the same as in for this yield? So it's yielding I don't know what this means. For yield. It's like yielding every single statement here or what? Same as do so for yield is basically same as do notation. Okay. I don't see the effects listed in the function. There's no annotations for the effects used, right? There's rand, which is random IO. But then there's IO slip. And the fact that you can slip is not listed in the type signature here. So this is not here, but you can list them if you use tagless final. Tagless final. IO is just a super monad with all capabilities. I mean, yes, but like the IO is still not listed in the in this function, no? Or is it just being inferred here? Or is it not like, or is it like based on runtime? Like you always have access to the IO. It returns IO unit because it's being inferred here, right? Yeah. Yeah, because it's just yeah. Okay. Sure. So is it a monad or is it an effect? It's a monad. So you're working with monads here, not with effect systems. Right? It's just called effects. ZIO Scala. Type-safe composable asynchronous and concurrent programming for Scala. A YouTube video on the front. High performance, type safe, concurrent. Overview. Implicit unsafe. Isn't implicit the part of Scala 2? In Scala 3, they do they do the using. They replace the implicit keyword with something else, I thought. This is the old library, maybe. That's why they have the 2.x, right? Not 3. So this is referring to the Scala version, not to the version of this library. Maybe. Running effects. Your effects are precise plans to describe a combination or interaction. Ultimately, every effect must be executed by the ZIO runtime. Default runtime, custom runtime, and reporting. In this section, you learn about several ways that ZIO provides you to execute effects. Print line, read line, print line. It still is all being inferred here. I want to like see. Custom run. It is a custom environment for your application. You may find it useful to create a runtime specifically tailored for that environment. A custom runtime R can be created with a Z environment R, which holds the context where in order to execute your effects, as well as fiber refs and runtime flags. For example, the following creates a runtime that can provide an int to effects. Runtime int. What are we doing today? I was doing the Haskell to write the parser for the AST of my language, and I became too annoyed with Haskell. So I am considering not continuing the Haskell and going back to the Rust. I don't know. I'm not familiar with Scala. I don't see like if I was just looking at this, I don't understand it. And why would this be good? Like I need to understand Scala for understanding this. Anyway. Sounds good. Uninstall Haskell. Yeah. What is like yeah. Yeah, I think I'm going to uninstall Haskell. Like I wanted to try the more advanced stuff in Haskell, but yeah. Too annoying. Quiz team. Hello there. How's it going today? Not good, not good. Not good. It's going bad. We're deciding we almost decided to drop Haskell. I'm just like I'm doing nothing right now, just waiting, just stalling before actually uninstalling Haskell. It will haunt you anyway, and you will get back again and again to Haskell from time to time, and that's what happened to you and Erlang. I don't know, but like, why would I come back to it? Like, I will like it's not the first time that I'm trying Haskell, by the way. I tried it before, like 10 years ago or something like this, and I had, I think, literally the same experience. I became annoyed, even though I like the idea of a language, of this language. I like the type system here, but it's just too annoying. So this is the second time I came back to it. Also, last time I because like I wanted to make games. Also, my impression was that it is very hard to write Haskell with predictable performance. I'm not saying fast programs, but like predict the performance of my Haskell program is really hard. But if I don't care too much about performance, like right now, then it will be fine. But for making games, I went with Rust, and it's good. Classic steps. First, learning Haskell. Second, dropping Haskell. Ah. Yeah. Well, at least no one is saying that I'm having a skill issue. You know, like if someone is like there's also like a lot of people who are going the same with Rust. They go into Rust and then they drop Rust. But I think in that case, that is a skill issue. I think in case of Haskell here, I am not dropping it because of a skill issue. You know, it is actually the language that I want to be better. You know, like it's the language issue. It's not my issue, okay? Everyone here have skill issues with Haskell? I don't know if I have a skill issue here. Like, be back to a game time is come. You'll clean the head. Yeah, maybe like I should go back and like work on Linksider instead for a little bit, and then come and then we'll see. Maybe I will continue OCaml, or I will like if I want to rewrite, or maybe I want to continue the Haskell. I don't know. You got really annoyed with your async-based app. You was writing in Rust and you wrote it in Go. Oof. All right. I cannot even like write a single line of Go without being annoyed at the language. Like I'm not sure what like. I mean, I have not written a lot of Go code, obviously, but I'm wondering which one would be more annoying, Haskell or Go. I don't know. Haskell issue is a skill issue. But you also realize you was over engineering, so probably have been redone in Rust and be fine. Do you want to play some nice open source Minecraft? What do you mean open source Minecraft? You made Minecraft, Nigel? No? Who made open source Minecraft? Would this perspective on other lang will be different if I was not a Rust boy? Or what? Minetest? Minetest is Minecraft written in C++, basically, right? Why would I play that, though? Instead of playing Minecraft. Not such a Rust boy. Yeah, I think if I did not learn Rust, then I would have less problems writing in other languages. Yeah, that's true. That's true. If I did not know a language which is good, then I would not complain so much about the bad languages. Yes, I think that's I think you're right. You're onto something there. Do I have Minecraft here on Nix? Yeah, I do. I'm using the Prism launcher so that I can. Yeah, I have. This has been a while since I played any Minecraft though. Yeah. Write it in Lean 4. A Lean 4. Lean 4 programming languages and theorem prover. Should I use Lean? Lean is under heavy development and we are constantly trying to new ideas to tweak the system. It's a research project and not a product. Where's any examples? Quick start. VS Code. Quick start. Examples. Palindromes. Inductive palindrome. List alpha. Wait, hold on. You are supposed to actually write the alphas in your code. I don't have a keyboard with an alpha key on it. What is this? What is this little symbol here? What is this? Oh, it's just like for... Okay. Sure. Goals accomplished. 15 minutes of Minecraft Skyblock. We're just going to wait 15 minutes for the first for the first tree to grow. And then I'm going to chop the tree down and that's it. The 15 minutes are over. Look at example 6.4, the well-typed interpreter. Infix 67. Why is it not 69? That would be so nice. They just too off. Inductive type, where int, bool, a function, argument and return types. We can write a function to translate type values to a Lean type. Remember that types are first class, so can be calculated just like any other value. How does this compare to something like Idris? Lean 4 versus Idris. Advantage of Idris over Lean. Idris is a dependently typed language that was designed for programming rather than proving. It can also prove things, and in fact, when doing independently typed programming, you often need auxiliary proofs, but its main focus could be on the making programming as pleasant as possible. Pleasant as possible? Is it more pleasant than the Haskell experience? Idris used to have C backend, it switched to check, to Ches, scheme, because we're actually faster. Are they saying that C is a slow language? What is Ches? Scheme, Ches, scheme. Ches scheme is apparently very, very fast. Isn't scheme the Lisp? There's not a lot to this README here. Revised report on the algorithmic language scheme. A superset of the language described in this, Ches scheme supports all standard features of scheme, including first-class procedures, proper treatment of tail calls, continuations, user-defined records, libraries, exceptions, and hygienic macro expansion. Scheme also includes extensive support for interfacing with C and L languages, support for multiple threads, possibly running on multiple cores, unblocking I/O, and many other features. Where is the thing? Get started with Ches scheme by building Ches scheme. Wait, what? By building? Oh, I need to build wait, what? Okay, they want me to build the compiler from scratch. Where's the definition? Where's like the README? Or are they saying that all I need is to know the scheme programming language, and then the Ches scheme is just like the implementation of that, right? What is this? Is this the icon of the scheme programming language? Just a bunch of like, is this the spaghetti? Is scheme programming language the programming language of the spaghetti? What's happening in this image here? That's a Lisp code base. Mm, mm. I'm sorry for anyone who was just blinded. With continuations, you can really spaghettify your code. Yes, I'm going to have continuations in my language too. Oh, it's going to be so much spaghetti. While any sufficiently advanced C program has half of common Lisp, every sufficiently advanced Lisp codebase has 33 other languages inside it. Yeah, so like in theory, my language should also be able to do the same. So like in Lisp, you have like this macro system, which is like really powerful, and I have the same, but without it being the list processing language. It's not really like we can define some nice syntax for it too, but it's the same macro system as in these Lisps. Like over here, we define the ternary syntax, left associative with priority 10. We define the syntax for it, and then when the compiler sees this, it's trying to like see what is defined for the ternary. It's a macro, and it's going to basically like it's just like a normal function with the ASTs that are going to be passed to it. And this is like the quoting operator from the Lisps, and this is the unquoting. I think you do the comma for the unquote there or something in the Lisps. If I start writing kast in Rust, my hope in humanity will be restored. Well, yeah. Maybe it's going to happen then. Do you think MT is a good feature to have in a lang? What's MT? Metaprogramming. Yeah, metaprogramming is a good feature to have in a language, yes. I think it is. So like, but it should not be like the only thing, you know? It's like metaprogramming is like the most. It's like it's not the first thing that you should try. Like you know how you can do a bunch of stuff with macros in Rust, but you should prefer not using them. You can do a lot of stuff with macros in C, C++, and you should prefer not using them. You can do stuff with template Haskell in Haskell, right? I did not get there myself, but I know that there is the template Haskell, and you can use it for a lot of things, but you should prefer not using it. That's one area where Rust is not good enough or too convoluted. Just something like creating codecs is a million times better if you have metaprogramming, and you can use TypeScript to generate Haskell. What do you mean you can use TypeScript to generate Haskell? To offload all this stuff to the compiler, you lose control and what the code looks like. You offload the stuff to the compiler, you lose control of what the code looks like. What are you saying? I mean, the meta programming, like one of the nicest languages with meta programming that I have tried was like the D language. There's also like the Zig, which is currently popular, right? Which has this comp time thing, which also is like meta programming, right? Which is kind of nice. It's just like a D language did it. They did basically like kind of similar things earlier. And yeah, like in Rust, the meta programming is like a different language. Basically, like the macro language is basically completely different from the normal Rust, but in something like Zig, you write the same language for both meta programming and normal programming, which is much nicer, you know. I think you should give Scala 3 a go, not 2, if you like Rust and you want more functional programming and more ergonomics. I don't know if I want to. I don't quite get all the defensiveness of now about metaprogramming. It's a good thing and not all that different from creating functions. Drop in Haskell for Zig? No. Zig, like Zig's comp time is nice, but it's not enough. Like this single feature is not enough for Zig to be a good language. Zig is lacking a lot of things. It has metaprogramming, but like it's not enough. I will not be writing Zig. MTP runs at compile time. Metaprogramming runs at compile time, and what it does exactly to your code is vague. For you as creator, it's clear, but for user, he don't know what or how it will be interpreted. Therefore, you lose sense. you are starting to type like to have even more and more typos over time. I feel like what you're doing is reality versus what you intended. Well, it depends. It depends. Like so, like the meta programming, when you use it, you should understand what you are using. You know, it should be like I feel like it's I don't know. Like the alternative to metaprogramming is runtime reflection, or a massive amount of boilerplate, or code generation. What's metaprogramming? You're still confused about the exact meaning of the term? It's I mean, it's generating code instead of I mean, isn't metaprogramming literally is the code generation? Like what's the difference between the metaprogramming and the code generation? It's because like you generate code in some other language, and then like instead of and metaprogramming is when you do it inside the language itself instead of like from the outside generating that code. Microsoft metaprogramming, yeah. Macros templates, that's metaprogramming. Is generics in Rust metaprogramming because they are not that different from the templates in C++. But I wouldn't say that it counts as metaprogramming, right? But like you write generic code, which basically like every instantiation of the generic function is like technically a different function. So you're technically what you're doing is also you're generating these functions, right? Like at some point, like when you It's like preprocessor is not metaprogramming. Generics are the limits. You think so? Yes. Like you can also do some metaprogramming with the type system technically, right? Like have you like I don't know if Raymarch is in chat right now, but Raymarch is working on this shader metaprogramming in Rust, and you write some Rust code and like it's done through the type system, and like using the type system it generates the shader code for you basically. Even although yeah, even although you're not really using like much macros, it's more like type level programming is kind of like this is kind of metaprogramming based on types, right? You're mostly creating an AST then? I mean, yeah, kind of, but like it's also like doing the type checks, right? When you usually do metaprogramming, like if you do use the C++ templates, you don't really like check anything, right? It's just a template without checking much. What are we talking about anyway? Hello, Pigorle. Preprocessors are working on text as characters, so you manipulate text to create program templates. Uses at compile time objects, which is metaprogramming. Well, I mean, okay, so you're saying that preprocessor is not part of the compilation then, right? You're separating these things. Sure. I mean, we are not going to have the preprocessor. Everything is going to happen at compile time. I'm not going to be working on text as characters. But I thought this is also counts as metaprogramming, technically. Because you can generate code with it. You starting to feel like there is a gradient from object to metaprogramming. You generate text with it. Yeah, but the text is a program. So you're programming a program. You're generating a code. But you're generating it in the form of a text. That's in C. In a language like in some other languages, like in Lisp, you are generating the code in a form of an AST basically. So you have an AST-based macros instead of text-based macros. But it's not much difference because it's not like I don't know. Anyway, what are we arguing about? It's does it make sense? I guess you asked if there should be like metaprogramming in the language, and I think yes. The more tools you have in a language, the better, kind of. Some of the tools though can be implemented as combination of the other tools. So we want to find the minimal set of features in a language, which allows us to be as flexible as possible. You know, that's the idea that I think is good. So we want to have a minimal set of core features which can be composed into other ones easily. There's a huge difference when you work at lecture level, when you work at compiler. Well, in my language, there is not going to be much difference because there is going to be just the compiler, or I call it interpreter. It doesn't matter. Like, yeah. there is no there is no difference between the levels. There's just like code, and you can run code at compile time, and you can run code in case of a macro which takes the AST as its arguments, so you can generate some code, but it still is the same language which is happening at compile time. There's a danger to metaprogramming the Lisp curse. But I wouldn't learn a language that has none. Yeah, I mean, there are things that can be overused. Like, for example, you can overuse this custom syntax stuff, right? Similarly to how you can overuse the operator overloading. But like, having a tool is still better than being annoyed at the fact that you need to like you know how in the Go language, I know that people for a long time, like Golang has introduced the generics recently, right? And I know that before that, people were using like tools outside of the Go to generate Go code, literally, because you can know because there is things that like otherwise you would need to repeat like a lot, literally. Right? Any Go programmers in chat? Do you guys know what I'm talking about? Do you still use them since they added the generics? Do you still generate Go code? Go code gen. That's another weakness of Rust, not enough operator overloading. Then you have the too much of it in Haskell. The problem with Haskell is not the too much operator overloading. I think it's just overused in Haskell. Yeah. Because operator overloading allows you to have like basically custom syntax, but you cannot. The problem with Haskell is bad naming conventions. Yeah, also that, I guess. We still use the code generator. It has more uses than generics. For example, the JSON serializer generator. Goat code gen. Yeah. So yeah, like because you still need that tool, having that in a language is much nicer. So like there should still be some way of doing like whatever you want. Yeah. Okay, I think I'm doing nothing. So unless I want to like play Brainoid's game, if Brainoid's still here, maybe we can play Brainoid. Brainoid wanted to do a post-gem version, so maybe we'll play it some other time anyway. Yeah, I think I will rewrite it in Rust. Do you guys want to see me rewriting the kast in Rust on stream, or do I do it off stream and I stream the link cider instead? No, yes. Well, that was an or question, not a no yes question. Minecraft? Alright. We can talk about some other stuff while I'm playing Minecraft. We are going to... No, hold... No. Oh, no, hold on. Alt F4. No. I don't want Minecraft. Sorry. I don't. I can give you back your points if you want. Maybe I should disable the check this out reward, because I'm not really into checking things out lately. Write an OBS plugin? Why? Because one, it's fun. Two, you have nothing to do. Three, you asked for ideas. Write something in Baby. No, I'm not going to do anything like that's long. That's taking a long time to do. And I have written things in Baby already. The only reason for me to write something more in Baby is if there's going to be another Baby Game Jam, right? But Baby Game Jam, the last one was like just recently that I missed. Baby Jam 4. No, Baby Jam 5, right? Baby Jam 4 I did participate in, right? Baby Jam 5 is the one that I did not do. This one was in July 29. Which means that the next one is probably going to be, what, like in January, maybe February, somewhere like that? Write some documentation for Gang. No, I think I'm going to end the stream instead. That's what I'm going to do. Ah. Let's just say that I have learned Haskell and I don't need to learn it anymore, right? If anyone asks me, why did I stop writing Haskell? I will say that I have learned it successfully. So I know it now, no reason to write it anymore, right? Put it on LinkedIn, then it's a fact. One more idea, if you're a skilled software engineer, so maybe have some open source PR to kill time on. I was going to like do the pull request to one of the Haskell libraries because their documentation is not rendered properly, right? What was it? The F extensible effects library, Control F over here. Like you see over here, this documentation is bad, and I was going to fix it. If we want to do some Haskell, we can like this is a rendering issue though. Over here, I was literally following the documentation, and this does not work because it's treated as a link over here instead of like some code that actually is written here. So yeah, I just don't know how to fix it, is the problem. And also, I think this library is not really used, right? How do I go to the source on the extensible effects? I think it's just not been maintained anyway. Like the last commit to this was 4 years ago. I think it doesn't matter. Make an issue on GitHub demanding a fix and then never use the library? Yeah. I don't know. I just raid someone. Is anyone else doing something cool that you guys know? Check on ban requests. Wait, how do I check on ban requests? Where do I go for unbanned requests? You know? Have you tried unbanning anyone? Is it settings, monetization, content, community, analytics, mod view? Where's the mod view? How do you go into the mod view? How to stream, guys? Oh shit, what did I do? What did I do? Undo. Control Z. Shit. Why are all the Rust streamers transgenders? I'm not. That's not true. Go to normal stream view and then the sword. So I need to go like this. Sword. Moderator, mod view. Take a look. Watch tutorial. Take a look. Watch tutorial. Now what? Not yet. I'm not transgender yet. Well, I guess you never know, but mod actions. Unknown user banned by Kuviman. Yes, I did ban someone. Unban requests. New syntax. The scissor will cut. New syntax. I don't know. Why did we ban them? 10 penguins? Oh, it's because like some random messages that make no sense. Yeah. The weird AI dude, yeah. All right. All right, let's just go somewhere. Nothing is happening. Nothing is happening. Nothing is happening. Coding mentioning. Coding mentioned. All right. I don't know where to go. Let's go to kast then. Do some C++. You guys like C++, right? We all like C++. Wait, he's going to play some game instead of.
Like, come on. You need to prepare for Bloon's lawsuit. It's transformative.
Or is he just looking at some things? Game dev when? Nobody likes CPV. What do you like more?
No, we are judging based on the differences between the two. And
The most annoying streamer? Who, the Cakes? I don't know. I think Cakes is pretty fun. A little toxic, but fun. You married it, only you have the right to hate it. Love CPP. Alright. Which means that I have the right to hate Rust. Which is going to happen. Next time I'm streaming, obviously I guess I don't want to write Haskell anymore, and I don't want to write OCaml anymore, so I guess we're going back to Rust. We're going back to hating Rust. Okay, Rust. Scala 3 just saying. I don't know. Like, what's really the advantage? Just to learn? I don't know.
So it should have gotten a pen command. Let's take a look there.
Rate someone attractive, please.
So we are
well, I'm not sure how this person looks, but they are probably really attractive. I was asking for you to play your game. Yeah, you said that you want to like do the update, so maybe we'll play it later then when you update it.
Oh, we're only setting
Right?
it locally here. Ah.
Okay. So I'm just going to end the stream then. See you guys next time.
Only setting it locally.
Uh,
So that when we
bye.
actually draw the turtle, and the turtle is being
Wait,
drawn
how do I do the raid now?
separately.
Dismiss raid. Bye.
No, it's right here. I thought it was being drawn separately, but